A number we use in math a lot is the number square root of 2. And we know that square root of 2 is, we could say it's the longest side of our 45, 45, 90 degree triangle. We can say a lot of other things about it, but more importantly than all of these things is that root 2 is an irrational number. Alright, and this is something we kind of take for granted when we do math. Because how do we know root 2 is actually an irrational number? You could say, oh, some old guy proved it 1,000 years ago. But it's really interesting to take a look at why root 2 is irrational, alright? And to do this, we do something what we call proof by contradiction. And proof by contradiction is we're gonna give a statement in the proof that we're gonna assume is true, and we're gonna later contradict it to prove this right here, okay? And so let's start off our proof right now. We're gonna say that root 2 is, we're gonna say it's actually a rational number, right? So we're gonna say that it can be written as a over b, where a and b have no common factors because they're in their most simplest form, all right? So we're gonna say a and b, no common factors, all right? We're gonna say that right now. And so we're gonna sort of manipulate this the statement right here, and we're gonna come up with this, all right? So let's square both sides. That's what a normal person would do, right? So we're gonna square both sides. We're gonna say 2 is equal to a squared over b squared, okay? And 2 is equal to a squared over b squared. You see what I did there, guys? Root 2 squared is 2, and then we have this squared, which is a squared over b squared, okay? And so now we're gonna multiply b on both sides of the equation, or b squared on both sides of the equation, to get rid of this fraction. So we're gonna say 2b squared is equal to a squared, okay? And now let's pause here. If 2b squared is equal to a squared, that's going to imply that a is an even number, right? Because if your output for, if we had a function, right? We had f of x is equal to x squared. If we inputted an even number, it will always output an even number for x squared, right? That's a given truth that we know in math. We can get into that proof later, but we're just gonna say we know this is true, all right? And if we know this is true, we're gonna apply it back here, and so that means we know a has to be even, right? Because if something is multiplied by 2, it has to be even, right? Divisible by 2, multiplied by 2, it's even. So we can rewrite our a as a is equal to 2c, right? Multiplied by 2, it's just gonna be even. And we're gonna say that a, b, and c are all whole numbers here, okay? So we have this, right? So we can substitute 2c back into here. So we're gonna say 2c squared is equal to 2b squared, all right? And so we're gonna square this entire thing right here. So it's gonna be 4c squared is equal to 2b squared. And then we can divide 2 on both sides. So we have b squared is equal to 2c squared. Now let's pause here. Again, we have b squared is equal to 2c squared. And that's going to tell us that b is actually an even number as well, right? Because we're multiplying this by 2 right here. And any square that is even has an even base, all right? So b, if a is even and b is also even, that's going to contradict what we said right here, right? Because if they're both even numbers, then they both have a factor of 2, and that is contradicting our statement right here. A and b have no common factors, and therefore that'll contradict this whole entire statement up here. And so that is how we know that root 2 is an irrational number, all right? And so I just think this proof is fascinating to know, right? So now you know your roots on why square root of 2 is irrational. I really hope you guys found this video interesting. I found this proof interesting. And I'll see you guys in the next proof.